so that we can resume our presentation today. So I'm very glad to be part of this group, and I hope we'll move together so that we make GE developers Nairobi grow and grow as we work together to solve environmental and socioeconomic issues uh, that are having that are like that currently is affecting us as a developing world or country to be specific. Yeah. So thank you, Nicholas, for that. I hope we will interact more as we continue.
Thank you very much, Michael. Michael is a special developer and also Google thinking developer. So we are really much glad to have this strong speciality here. Next, we are going to have Michael Christopher, who is also a co-organizer for this. Please, Chris.
Yeah, so good afternoon, everyone. So I'm Christopher Wanjohi, part of the organizing team. We are privileged today to have our speaker with John Esther. So I believe he has a lot of expertise in this GIS. He has done it for years. So if you have any question, feel free to ask during the session in the chat. You can raise your hand or you can now unmute your mic. So feel free. We will welcome you to this session, and thank you so much.
So at this moment, we are going to have our speaker, John Esther. John Esther is a consultant of GIS and also a Google Earth Engine developer. He has done it for several years, and all his time of professional development, he has worked mostly in Google Earth Engine and all that is related to GIS. So at this moment, I'm going to welcome John Hester. John, you can just introduce yourself briefly, and then you can tell us your background, your professional journey, how you got into this, and how far you are looking forward, and what the future of geospatial. Welcome, John.
Thank you everyone for having me here this afternoon. Uh, I hope I'm audible.
Yes, you heard.
Yeah, so if you hear some background noise, my office is having some renovation, so you might hear some noises that are not good. So just bear with me. Okay, you have said I've been introduced. I'm a data scientist right now. I specializing in geospatial data analysis. I've worked in the industry, geospatial industry, for the last 10 years. So I've grown with it from being totally dependent on desktop applications to actually just writing code and getting the results. So I've worked with Google Earth Engine, both the APIs, and that's something we need. I think I should have asked before time, but today our code will be on using Python, not the Google Earth Engine interface itself, because uh, it was supposed to be an application that you can port and put it anywhere else, not just in Google Earth Engine as per se, the way we create the normal apps on the code editor. So I hope we are good up to that point. Yeah.
Yes, yes.
Yeah. Okay. So I don't know if, without further ado, I don't know whether we could get started. Are we live coding or am I just showing you the app? Chris?
We would appreciate getting to learn the the hands-on part, because that is really matters for the learning community.
Okay, okay.
I think also probably because of interest of time, you
Yeah.
could be
Yes.
showing the specific portion of the code and what it does, so that yes.
Yeah, yeah,
Thank
that
you.
also a good approach.
Yeah, so because I asked this because I had made the assumption that everybody actually knows how to set up, say, a virtual environment for Python. So I don't have to redo that part. But if you need help, I can help you do that. I can also direct you to like a link where you can set up your environment. Yeah, so that's the reason I didn't want to set up, like, say that start doing that. This is for Mac, this is for Windows, this is for a Linux machine. So that's one of the things I overlooked. Okay, a second. Is my
It's visible.
it's visible? Okay,
Yes.
I actually don't want to present it because I know it will run off into the other screens. And then I have to reshare that back. So yeah, so today we'll be talking about water quality analysis using Google Earth Engine, and we'll be using Sentinel-2 imagery because currently that's the highest quality free imagery we can get. So that's what we are using, but the same logic, same code can be used for any other imagery sources like Planet Club imageries, which are like 3 meters. So it's not really just specific to Sentinel. It's you can do this also even with Landsat 8, Landsat 9, but at this moment, Sentinel is kind of the cleanest image we have right now. So that's what I'll be using today. In this case, we'll be talking about a very specific water quality. You know, there are some water qualities that you do with satellite and some we cannot. And one of the major water quality issues that we deal with this, especially as a country, is the turbidity, so that you can be able to evaluate what will be the cost of you cleaning up that water. So that, and then also knowing where you can actually go to tap your water that is not as turbid as another place. And this I'm talking to because I also have experience. I've worked in the water industry in the country for like the last 6 years, and it all involves this kind of analysis. And so today we'll be talking about turbidity specifically, and then we'll talk about normalized difference turbidity index. Now, I think turbidity, everybody kind of understands what turbidity is. Turbidity represents the amount of sediments that is suspended in the water. And this sediment may not necessarily be just soil, it also might be algae. But for algae, we use another index where we kind of look for chlorophyll index. And that one we won't touch today, but I just want to put it out there that it's something you can do. Uh, so uh, so this represents the sediments, and as you can see on my graphic here, you can see what I mean by that. Like on the light, you can see there is low turbidity water, that's very clear water, and then there is water with high turbidity. So initially, you can see that traditionally this was a very expensive exercise, because that means you have to take your beakers, go to the river or the water body in question, and measure get some water and put a meter, an EC meter. Most right now the EC meters do show the turbidity, but then in the past, beyond that, it used to be taken to the lab and then it's analyzed, and then you can be given the level of turbidity of your water. So, but in this, but that meant you had to have a lot of time. You had to use a lot of labor to go to the field and do that. But then, with the invention, with how we are using now satellite imagery, we can now be able to measure this in a different way. Like, so we use something called normalized difference stability index. And this is a satellite-based index for mapping water quality or water body in turbidities. So it uses this, I think everybody here understands remote sensing. And in this case, it uses this phenomena of the electromagnetic wave that like the reflectance is always going to be higher in greener spectrum than the red spectrum for clear water. So that means you are able to know which is clear water and which is turbid water because of that difference between the green and the red. And so in that sense, we calculate the normalized different turbidity index using the red band and the green band. And that's what I told you, like you can use any of the satellite imagery available because of all of them will have a red band and a green band. They will be measuring that. And this, I think these are the most common bands that any satellite camera will have. So you calculate it by doing taking the red band and then subtracting the red band and then dividing by, as you can see this formula, the red band, and then you add to the green band. So like any normalized indices, this index lands from -1 to 1. So and then this means that, and if you can see from my graphics here, when I say -1, it's this side of the clear water. And then you go, there's this spectrum that lands all the way up to high turbidity, which is a +1. This is water you can barely see. That's the water that's quite turbid. So so I want to really get off the presentation. So I hope we are getting well. Okay, you can give me good feedback there on the chat so that I know whether we are going well. So yeah. So this, then we have this is how we're gonna set up our like our application will learn in this way. We have we'll use Google Earth Engine like normally because we need to be able to process that a lot of imagery, which is where Google Earth Engine shines in. Then we will instead of using the JavaScript API, we'll be using the Python API for that. And then we will do Forium. Forium is a library in Python for visualizing geospatial data. Then there's Branca. This is for you to create nice color lamps so that you can visualize your data correctly. And then we'll have Streamrate. Streamrate is an application that helps you, like it's a library that helps you prototype applications very fast, such that you just from your normal Python script, you just learn it with Streamrate, and then you are able to visualize this in a web browser, and then you can host this very easily also, because I think the Streamrate crowd, the hosting crowd for Streamrate allows you to have like at least 1 or 2 applications for free. And then you have GeoPandas. GeoPandas, it seems I can see most people here are data scientists. And I think GeoPandas, if you have used Python, it's one of the tools for analyzing spatial data for in Python. So those are the main tools we will use. And then you have, this is our workflow. Is it visible?
Because yes, it's very visible.
Yes. So what we will go through this. Our code will go through this. goes through the step by step and how we do this. But then the main flow will be like we get the Sentinel image, we extract the bands we need, then we use we create because right now I am assuming you don't have any shape, any polygon that represents the water body. So we're gonna use the normalized difference water index to generate the water index and create a mask that represents the water body. And then we will use this water mask as the geometry for which to calculate our normalized difference stability index. So this is the workflow that we will use, and with that, so at that point, who is lost and who is not lost?
At this point, for me, I'm okay.
So
People are
yeah, they are quite. Before we continue, let me know how many people here actually use Python for data analysis. Yeah, you can just drop your your answer. So Chris or Nicholas, I think I wish there would be a way to know how many people actually do that are in the call, because it means I need to figure out which group, how to work with them.
okay. So you would love to know how many are Pythonese?
Yes, because we will. The whole thing is not really how to write the code. It's setting up the environment for this development.
Yes. Yeah, I think on that aspect, because you realize that working with Google Earth Engine, both in JavaScript and Python API,
Yeah.
there's not much difference. So I think the more task here is actually connecting the interface, the Google Earth Engine interface into Python.
Okay.
Yeah, so I think I request John Esther for you to focus more like on connecting the interface first. Yes.
Okay. Let's see. Yeah, because I think I kind of prepared for a different for a different. No worries.
Okay.
Yeah. Okay. So I think everybody knows this interface.
Yeah, this one we are familiar with.
So for you to set up a Python environment, what you need is to change your normal. How do you do this? Okay. Uh, I'm trying to look for that. Okay. Wait, give me a second. I stop sharing. Okay.
Yep.
So this is the method by which we enable for Python to use the Python API, you need to actually enable an if there's engine project onto your account. So most people who used Google Earth Engine since its beta version, you know, we didn't have the Python API back then. So, but as we have grown with Google Earth Engine, it has changed how you authenticate Google Earth Engine. So what I've done here is we need to go through this aspect of enabling. You create a Google a crowd project, and then we able. So let's go through that because I hadn't prepared for that. This is something that now every one of us is actually doing from scratch. Okay, I don't know whether that's good with you.
Yes.
Okay.
Yes.
Yeah. Yeah. So if you know, if you look at your, let me see, at your interface, I need to know how many people have, how is this logged in for you? Do you have a project? Maybe I'm trying to figure out whether I can get another computer that doesn't, or another account that doesn't have has nothing enabled here. So I need to know, Christopher. Is your Google Earth Engine account enabled to use Crowd Project?
I think Chris is not, but for me, I usually use it, but I'm not enabled
it's enabled.
to use the Google Cloud Project.
Yeah. So what we need, let me change, try to change that here, and then we can walk through that. Okay.
Yes.
Yes.
Yeah. So at this point, when you press your screen there, you should see the crowd projects that you are that are learning. So in this case, what I want to do is register a new crowd project. Okay.
Yes.
And so for everyone else, this is what we do. So once you go to register a new so this is the interface that most of us have used. We have used beforehand. Everything we used was used without a crowd project, isn't it? But lately, since they made it commercial for some people, this is it's not a recommended way of learning your crowd projects. So I want us to go use with the crowd project. Are we together?
Yes.
And then when you get here, you use the unpaid usage. Okay?
Yep.
Then you need to decide which is this. And for me, even right now, I'm confused whether it's training or is it academia. So somebody help me. Yeah.
Must be training.
Yeah. Okay. Let's assume that's what it is. And then
yes.
so once you are here, so I am assuming everybody doesn't have a Google Crowd account on their whatever email they have. So if you had a new a crowd project already existing, you could just go and choose the existing Google Crowd project. Okay.
Yes.
If not, then you want us to create a new, okay?
Yep.
For organization, you don't have any. Most of us will not have any organization with that account. This will be your ID. So for me here, I need to change it to. Let me add something else. So whatever you call your project there, okay? That should be your
Yep.
project ID, and then you give it a name. So for this one, I'll say G. Okay. We are together?
Yes.
Okay. So you go continue to summary. So I hope yours is faster than mine. Yeah.
Confirm.
So yes, so you see we go to confirm and continue. And there we are. Now for me, I have other tools from the way before Google Earth Engine was usable well. So let me get rid of that. So we don't have anything here. We are not gonna use anything here. So what I want us to do is I need you to come to and go to this site. You see, we have done all this. We have created a crowd project. So what we need to do is we need to come here and register a service account. Okay. So this is how we go about. You go to console.google.com. What have I done wrong?
Console.
Oh, okay. Okay, this is it's. So the question is, I don't know. I'm sharing that on the link.
Yep.
Okay.
Yeah, sure.
So is everybody at that? If you lag behind, just let us know, because I mean, as we said, it's a community. We are here to help each other. And then you can see me,
Yes.
for
Yes.
I already have had another project. So so if you are like me, you had other projects, what I want you to do is come here. It will open to this what we call the dashboard for Google Earth Engine. So what you need, like right now, I'm already logged into my default crowd project, but for now we have created a new one. So what you need to come here is select this tab here. I don't know what to call it. It's called select a project. And then it may not be visible here. So what you need to do is go to select all, and then select whatever project it is that you want to use. For me, this is the new one I have created right now, as you can see. So I click on that. So it comes,
Yes.
and then you come to these three dots here on the side. This, if you have used Google Cloud before, you are probably finding this very tedious, but this is how you go it. And then what I want you to do is I want you to go to APIs and services, or rather, okay. Then you go enable APIs, and then search for Earth Engine.
Yes.
Yes.
And then you click on that API. I see already it's enabled. For if it's not enabled, uh, yes. So it should be enabled. If it's not enabled, you should click enable. Okay.
Yes.
Yes.
So then what I want you to do is go back and go to IAM, the admin, and go to service accounts. Okay.
Yes.
And then you
Service
come on
account.
top here and you create a service account. So service account, you give it a name. So for me, I'll say it's GE and GE training. Okay. And what I usually like to do is, you can see there is something that has popped up here that's called email address. What I usually do is I copy that to clipboard. So once I copy that to clipboard, then I can be able to have it there. I'll use it later. You can give your service account a description. Like for me, it's GE training. Uh, okay, I want you to continue. Uh, and what I want you to do is give this account a role. And the role I want us to give is as agent. Yeah.
Yes.
At inch.
Yes, you see this that role here called as agent resource admin.
Yes.
Yes. Okay, you select that role. You continue. For currently, let's get done here. Anything else that raises up, we can go. And I hope that that has been clear up to that point. If we go back to the to okay. This what we have done here. Create and register a service account. If you come here, let me share this also. So for those ones that are being left behind,
Sure. Sure. Sure.
so this is the link. So what we have done for service account is following this one here, this other link here, how to set up it, how to set it up and give the permission. Okay.
Yep.
Yes.
Yeah. So that's what we have done. So this is what we the next thing we need to do. We are still here at the not there. Okay, here. This is where we are. So you are to say done. Okay.
Yes.
Yes. So what once that is done, what I want you to do is click on it. Okay.
Yes.
Yes.
Once you click on it, there is somewhere called keys. Okay.
Yeah.
Yeah.
And this is what I want us to create a new key. And should be a JSON key. Okay. For now, we are giving all this your project access. So this one is what we will use. So once you click that, it should download. You can see it has
Private key.
downloaded.
A key.
Yes, yes. You should have seen it has been downloaded and put into your computer. Okay.
Yep.
Okay. But somehow my stuff is so slow. Let me turn off some things. So you can see now you have an active key there. Okay.
Yes. Yeah.
Yeah. So with that, you have authorized Google Earth engine to be usable. Using that key, you can log into your Google Earth engine from any Python application. So let's we go do that next. So let's find mine. So I hope you remember where your key is.
In a certain folder.
Yeah, so whatever it is, so uh, okay. Okay. Sorry for that. So this is my key. So what I want to do is I want to rename this key so that I will remember what it is called. Okay. So this is just me. So if you can remember your name, no problem. You can remember the name of the key that you have downloaded, then that's okay. So remember where you have it. So now, as I can see, somebody is asking whether we can get the instruction as a PDF. I think the video is being recorded.
Yes. I'm recording the video.
Yeah, so you'll be able to get a link to that. And probably after a while, you might also I might also get it from Christopher and also put it in my YouTube channel, and you can follow up there. And you can ask me any question there if you have one. Okay, so we have reached that point. Yeah.
Yes.
Now
Yes.
I have the next question where it becomes tricky for people. Which IDE are you using for your code?
VS Code.
People are using Visual Studio Code.
Yes.
Okay, let's go do that then. Uh-huh. And don't worry if you can't find. I had not really prepared for to do this. So if you see something wrong, don't worry. So right now, what I personally don't use VS Code a lot.
Yes.
I use a new tool called DataSpell from JetBrains. But I also have VS Code for cases like this. I hope it's still working.
You have not been using it.
I update it and then I leave it alone. Oh, okay, it's working. So so what I want us to do is now we want to create a new project. Okay.
Yes.
So this is the normal ways we do this. So I want us to open a folder and was ignore that part. Okay. So for me, okay.
Yeah.
Or do you want me to create a new project altogether, like a whole new folder? We work by like step by step.
So I think you had okay. I'm thinking since the
Yeah.
other one had the same now configuration,
Yeah.
so you can just use the other one. But now
Okay.
just the starting of the project can just be the same.
Okay. So what you need to do is the thing is there's a whole section on setting up a virtual environment to use with Python. That's something I may not be covering here. So the question is I'm asking whether we cover that or we don't?
I think
Because the problem is everybody has a different machine. You find people are using a Mac, others are using Windows, others have an
yes.
Ubuntu.
Uh, um,
And
I
you
think
can,
yes.
yes, Michael.
Um, yes. So that's a concern,
Yep.
but I don't think I'm not so sure because the time.
Yep. What time are we supposed to end this?
No, I think
Nicola,
I think we had some good time for this for the project. So around five, just a sufficient time to complete the project you had prepared for us today.
Okay, okay. So then let me say this. There's a setup we need to have for setting up a Python environment that I actually had not intended necessarily to cover. But I am realizing now maybe it's something I should have thought about. Like
But
everybody
So
does
so
it differently. That's the whole problem.
I think
yeah.
we would assume that most of us have already the knowledge of setting up a virtual environment.
Okay, okay.
Yeah, so we
Uh,
can as well share after the session how we
yep.
can now someone can set up the virtual whether it's in Mac, Linux, or
Yes.
Windows. Yeah,
Yeah, so I have sent, and that's something you Google. Like that one shouldn't even be a problem to
yeah,
anybody who is doing coding.
sure.
I've shared for
Yeah.
you a video from my channel that has how to set up on Windows 10. So if you can look at that, but that's not definitive. That's like 2 years ago. It's still the same setup, but you can do that. So this for me. So we are here at VS Code. I'll select this project here. That's the one I had prepared to work on. So I select that folder for me, and there we are on our project. Okay.
Yes.
Yeah. So remember that key I told you had downloaded here? Yeah.
Yes.
Yeah. So you need to copy that key and put it in your
In a file.
yes, in our folder that we are using. Okay. I kind of struggle so much with VS Code, guys. Yeah. Yeah.
Yeah,
Uh,
yeah.
yeah, so let me with that this was just the setup. Now if you know how to work around Visual Studio Code and you have the project ready, then you just copy in your key here, and then when you want to initialize Google Earth Engine, I want to open this here. uh, Ignore the rest of the code, just zoom in to what is available. You see how we are, when we want to initialize our Google Earth engine in Python, yeah? Uh, it's not visible.
Maybe you can zoom out.
Yes, guys, who, uh, eh, guys, you guys who use Visual Studio, can you tell me how to zoom in here?
Okay.
You figured.
Okay, on.
This cannot be seen. Missing.
It should be a quick, I think it should be a quick thing.
Yeah, I'm trying to.
Appearance.
I'm trying to check. Zoom in.
It should have a key. I know it. I got it.
Now,
Control plus is equal to.
No,
Okay. I think
oh,
I think we figured it out.
no. Uh, I'm trying to launch mine so that it can show. But Lois is saying that you control and then you mouse dragging.
You control and mouse drag.
Yes, but it's visible now.
Okay, okay. Uh, drop this.
Fantastic.
So, you know
It's
that
okay.
that whole story we have gone to create a project and create a service account and create our keys. Yeah,
Yes, yes.
it's just so that you are able to initialize your Google Earth engine without errors. Anyway, don't worry. I'll share this once I work on a good repo. I'll share this on the with Chris, so he can attach it to the video. So don't worry too much. But this is our project. The way I want us to go through it. And this, remember, this is our workflow, and we are not implementing anything that's outside this workflow. So we will take this step by step. I just don't know how to share them both so that you can see, but this is the how the code is working. Uh, so let me ask, can I switch to data spell?
Yes, yes, yes.
Yes, because now this is the so it works the same
Tool use.
whichever you are
Yes,
using.
you can because the environment is
Okay. Okay, okay. Let me drag it to the next screen. Okay, just give me a second. Okay. Okay, okay. So let me cut off the. Okay. Uh, there we are. So sorry for guys. I'm very particular about my ID. Sorry for that. Yeah, because it's easier for me to work here. It's just just being used to it. So it's nothing big. Uh, so here we go. So as I have said, this is our workflow. So let's go through the scripts that show you how to implement this workflow, and then how you visualize that. And then we will, from there on, you can suggest anything that you need added to this, how to visualize it, and then at the end of the day, you'll have a very full application. What I've done, let's do this. I need to cut off also this browser. It's taking a lot of the memory. Just need to go. Okay. So, like I said, these are our applications that we're gonna use. We will use Google Earth Engine. So this is how we import all files in Python. This import date time. This is for just working with time data in our script. Blanca, like I said, is for creating good color ramps for visualization. Is it visible, by the way?
Yes, yes.
Okay. Then we have this EE is for Earth engine. You import Python. No, now. We import Google Earth engine as EE. Then we have Streamrate. This is for visualizing our app in a dashboard. Forium is for visualizing our maps, which is also these together. They are libraries in the same section. And then GeoPandas is for actually manipulating spatial data. So like I said, all the whole steps we have been gone through so far is so that when I initialize my Earth engine here with the key and the service account, remember the service account we copied, it means it doesn't ask me to go into a website and log in. And this, remember this, this is when you are doing development work. So I wouldn't recommend this for production work. For production work, all they should be kept in secret. Okay.
Yes.
Yes. So this is what we do. So once we initialize our service account, then this is just page setup. This is just aesthetics. So they should not really concern you so much. It's not part of the what makes the code work. It's just what makes the web application beautiful. And I can show you like a snapshot of the web application here. This is how the app will look. So that's just helping at the background on some here on the settings. So just remember that. Then what we do, this is our title. So this is some of the things that any application should have. So we use Streamrate to generate dialog boxes for you to enter the data, the point where you want to be. So right now this could be made better. Now it's asking you to give it to give a coordinate separated by a comma, that's the latitude and longitude. So it takes that, that's the one, it takes that point, it takes that and creates a buffer around it. Yes, Luis, well, you get the code. Once I refactor some things here as the keys, I'll put that in a GitHub repo and it should be attached to the video. Then there's another input. So this all these lines of code here are just what you see on the sidebar here. Okay.
Yes.
Yes. So that one I won't spend so much in it. Those four there, it's the buffer size you want, the end date and the start date of the imagery, and the coordinate. So then we have a script here. This one I don't even want to explain it at all. This is for I'm sorry to say this, but this is it's a class to help you visualize your files from Google Earth Engine on a platform that's not Earth Engine. And this is supplied actually, it's in one of the tutorials that Google offers for Python. So this is, that's why I say I'm not talking about it. I can find the link. I don't have it right now, but I can send you how you work with Python API there. So that's why this is there. So, and then what we do is we have defined a class. And then what we do is we add that class to our Forium system. This way it will help us to visualize our data. And then so this is our code as we handle most of the input. So you get now, you process whatever data you got in, you process it as to latitude and longitude, and then you buffer it by the size you inputted here. Where it is, put the buffer size there. So you see it, you put 2, in your mind it's kilometers, so we multiply it by 1,000, so that because most of Google Earth Engine uses Google Earth Engine, most of it uses meters, so you multiply by 1,000 to get the buffer you want, and then you create an area of extent for your area, for whatever you want to do. So if there is an error, then there's no point in you continuing, so it returns nothing. And then if you have an area of interest, then you create functions. The first function you want is to calculate the NDTI, which is normalized difference stability index. You get the red bar from your images, you get the green bar from your images, and then you do a bad math, which is, if you have used JavaScript or API, it's the same. Like the code doesn't change in that sense. So what you are doing is you're getting the red bar, you subtract the green bar, and then you divide by the red bar and the green bar added together. So this is how Google Earth Engine interprets this. So that's the function to calculate NDTI. And then the other thing you do is, normally you get your image collection from Copernicus, filter it by the area of extent, filter it by the date, sort it by the clouds, and then pick the first. Okay?
Yes.
Yes. So that's what we have done. And then you get say, and then there is also that now for NDTI, normalized difference water index, that's already it's already set up in Google Earth Engine is normalized difference class. So this class is the same one you will use in JavaScript, the same you will use in Python. But what we have done here is we are oh, that's so much better. You calculate normalized difference water index using this code for normalized difference. Then the next step, remember we are following here, so don't get lost. We have already gone through here. We have gotten, this is where we get the Copernicus correction. This is where we extract the bands we need. Then we do normalized water difference, which is here. This is the step we are at. We have not started this one. We have just created this function here, not created it. So we continue on that. This is where we now start to extract our water body. Like we said, if you look, this is some of the, just go in the future, look up how to calculate normalized difference water index, and you realize most of the values that are greater than 0, which is what we are here, they usually indicate water. This may not be accurate sometimes, I mean, depending on satellite imagery and the fact that right now I have not, there's some background I have not done. I have not really even cleaned up the clouds from the satellite image, which is another step you can just add to make your analysis in what we call, better. So what we are doing here is we are saying all water bodies are indicated by values of NDWI, which are greater than 0, and then you mask them out. Okay? Up to there, I hope I have not lost a lot of people.
Up to there, we are good.
Okay. So, and then what we are doing is we have gotten our water body. These water bodies are within our area of interest. So what we do next is we use the function we had created here to calculate a normalized difference water index. We calculate our turbidity index on the satellite correction, and then we clip that to our water bodies that we extracted from normalized difference. Okay, so
Yes.
at that point we have reached this section here. Okay,
Yes.
we have gone through our application. So the next thing is now this is just to calculate some matrices. You calculate the statistics for the NDTI, that's the minimum and the maximum values that you have. This is just for visualization. They help me to know how I will create my palette for data visualization. And then I also calculate a mean. This is just for reporting. This is another function to calculate the mean from the NDTI. We are using reducer functions. These are all Google Earth Engine functions. So this we use the reducer by mean, and then we get the mean. This will be for our reporting. Then so we get all these values here. We get our minimum, the maximum, and the mean of the NDTI for our area of study. So the next thing is we print it out. Okay. Now these other steps you can see here are just for helping me visualize this data. So what I've said, like I said, NDTI is between -1 and 1. So that means for me to visualize, I have to figure out how to spread the color ramp. So what I do here is I kind of take the crypt data and multiply it by I get this and multiply by 255. Okay.
No, yes.
Yep.
But would you mind explaining what 255 mean?
It's just the color. Okay. How can I say? I'm just trying to stretch our values.
Yes.
They are between. Right now they are between. Now for NDTI, you see we have picked up the values that indicate turbidity on our water, like indicate turbidity on our water bodies, but it
Yes.
ranges from -1 to 1.
Yeah.
So what this doesn't change the values. This is actually not what we use for reporting. This is for visualization. So for visualization, okay. So for visualization purposes, it's I think I find it better to just use a color ramp that runs all through the. I'm trying to find the best explanation for that. There's a reason for 255 in our image. So
Yes.
yes, there is. Let me find. I'll find you. I'll find an explanation for that. I don't know how to
Okay.
put it well at this point,
Okay.
but I am just stretching the value so that I can have a longer color lamp to use. And there's also it's also because of the image definition for that, because my image would be uh, eight what we call that 8-bit. My image here is coming as a 8-bit image, which has values ranging from 0 to 255. Okay. Yes.
Yeah.
Yes. Thank you, Michael. That's the word I was forgetting the word intensity. Thank you.
I like.
I'm welcome.
Yes. So yes, so that's why I'm doing that. And then so this then just I had added a way to export our water body as a shape file. This I'm not sure, I haven't tested it whether it's working, but I know this is what we do. I'll try that. I haven't really actually tried. So if it fails, just be confident that it has failed here. But if you get the code from GitHub, it will be working. Okay.
Yes.
Yeah. So, and then we come to our visualization. Like we said, each tool has a different purpose. We have used Google Earth Engine for our analysis. We have used GeoPandas to create our area of extent from just coordinates. Now we have used Streamlit to create the application with including the interface. And then now we are using Forium for visualizing the map. So Forium, we do the same. We get the map function, we get the center of the map, which will be the location that we had input, and then we start at zoom level 14. I know when I explain this, if you're here, you'll probably understand this from this juncture. And then you create a color palette for our NDTI. That's not the one I'm using actually. I'm using this. This is the one that we are using. And then we take this colors and we put them in our in Branca color ramp. So this Branca, we are using this class to just generate a nicer looking color. This is just all for visualizations purposes, and also it helps me create my legend. So this is why I'm basically the reason for using Blanca is that because I can generate this and put it as a legend. And then finally, what we do is we add all those layers we have generated. We generated our Sentinel image correction. We got our bodies from NDWI, and we got our turbidity index from our NDTI, and then we add our color ramp, and then we add the layer control so that you can turn stuff on and off. And then you come here and you add this is just to visualization purposes to make the map big and visible instead of using the defaults. So that's all our code there. Okay. And
Yes.
and now because these things tend to be really terrible at on presentation time, let's make it work. Okay. So if I do this,
Stream read run.
okay. This is what I was saying. This is just ignore this. This is you should be able to set up on your own personal environment, and this is where you activate your virtual environment. And then what we want to do is learn our Streamlit app. So the code for running any app in Streamlit, I'll put this back into a README file. Is you do Streamlit learn your application. Okay. So let's see if that works. Okay, so we are learning a Roku server. Okay. It's literally learning. Okay, so.
Oh,
Yep. Let's try this. So what I usually do is I get some coordinates somewhere. This one should be much better. Probably I'll change it to this after this. Let's see what happens. So this is a very good. Error. It's telling you where your problems are. Okay. And
yes.
so it can't get, it's trying to learn things, and already I had told it to stop if we don't have inputs here. So, okay. So I have, like I said, you put in the comma separated latitude and longitude, okay? So that's what it is. Let's see where it takes us. Seems we have some answers. See what it shows us. Okay. I think my image is too big. Okay, I have too many images. I have too much crowd.
Yeah.
I'll try to set this up. Okay. Let's try to find a place where it doesn't have too many crowds. Let me see. This is me just trying to figure out where. So if it has this many crowds, I should have added a code to handle. Yes. Yes, Lois. I can set the coordinates on startup. So yeah. So this is our area code. This is our certified somewhere else that may look better. Let's see if this one is any different. But so whatever you are seeing that is log, it's because of our crowd cover, which we should handle them in a different way than I have handled it in code. Okay. See that one? Because we don't have many crowds. Okay. You're doing okay?
Yes, yes.
Yes.
Yes, yes, yes.
Okay. Yeah. Also,
This is very
it seems when I am presenting this, mark gets off my screen. So so let me reduce the width to allow, say, 1,000. And let's relearn our code. So whatever you can see here on the dashboard, this is just Streamlit to makes it okay. Yeah, just now it's zoomed into our area. So I think it's all visible now.
yes.
Yes. So yes. So like we have seen, like this is you see, like for this image, there are some areas that it did not classify as water. So our error is really coming from NDWI, from our not from our, and also the time I have taken here, you can see it's 2020. You can change it to whatever time, the date you need, and it will work. But what it's telling you, like when you see lead, it's telling you at this juncture here, this water is totally turbid. Okay? Yeah?
Yes.
This is water, this river here is full of it's fully turbid. It's not visible. So this also guides you when you want to do other water quality tests. You can see this is the same river, and it comes flowing. Whatever is coming from the other side, it has better quality than the other one, the main river. Then you go down through the channel here, it failed actually to recognize this as a river. So we don't know how we need to deal with the NDW to extract the river channel. But this is the other thing. If you have water, what to say, like if you have a polygon for the water system already, you can just put that. That's what I thought of adding here, and then I realized there wasn't much value into that. But you can put in a shapefile, get the JSON of it, and you will use it to create your water channel, instead of actually you going through the step of calculating the NDWI. You don't do that. You do NDWI beforehand, and you get your rivers or your river water body. Then you use that polygon for your water bodies to now work with the turbidity index. And you can see as we follow through the river here, you kind of notice this is how you would expect it to be. Like through the river, because there's less water here, it is very turbid. And when it's getting into the channel, it's also very turbid. And but here on the edges, you can see it's clean water. Yeah. And then this is a dam, so you can imagine as the water goes in through the dam, it drops most of its sediments, and by the time it's in the middle of the water reservoir, it is at zero turbidity. The water is clear. Okay.
Yes.
Yes. So, in a nutshell, that's how you do water quality analysis using Google Earth Engine and Python API. And in the past, this is something that would have taken you a long time. But with the ability to just use a huge amount of satellite images just through an API, you can now do a lot more and faster implementation of project. So like now you know the point you need to go and look at water quality issues. So probably by this point where this is so red, it means there might be something that's happening here that you need to investigate. Well, here when it's clear, you know, well, this is normal. So yeah, so this is what I expected to do. And now this analysis, you can combine it with other things. Like we have something we call chlorophyll index analysis. So you analyze the and I think somebody has done that. I think I should look for that. They had done something like that for Kenyan lakes, so that you can be able to identify the presence of water hyacinth. Oh, that word, I don't know how to say it nicely. So yeah, and so that's how you go about it. So and that means we finish our workflow. Now, for practical applications, for practical application, this is what you would use this kind of analysis for. You would use this to monitor water quality, because if I added a new date here, I could come in here to the code. Is it? Sorry. You could come in the code here and add another set of dates to compare these two systems across different time zones. Like now, if I probably came here and changed this to, and I hope it doesn't break, say to, let's go, we look at the month of March, the whole of March only. So the problem is there's very few images there. And then it recalculates. Probably this changes how the water quality looks like. And then we can do much more that, like you compare that. So as it runs, let's go through this. So there's something else you do when you are working with turbidity. You can use whatever code we have generated, and if you learn it, and especially with areas where you already have you are not introducing errors of calculating the river channel by using NDW, you just use the river polygon. You can detect where people are doing pollutions. Like you can see where I was telling you, like you can see here at the, oh yeah, the crowds have made this a mess. We need to handle crowds. You see, this area is fully covered by crowds.
Yes.
Yeah, when it's covered by, so the month of March was a disaster. We can't work with. So for the way I'm using for this, I'm using kind of the whole year to get which one day that this one was, everything was quite crowdless. So the other thing is you would do is you could create a mosaic of a crowdless mosaic for a period. Like you say all the images of March, and then you remove the crowds and merge them together, and then you use that to calculate this. So yeah. So as it runs, let's see something else. Oh, that's failed. So the best month was January. So that. So this is what you do. Like you can detect pollution events through time. So you can know, like at a certain point the river got so polluted, and then it is stopped. So you need to investigate actually what happened. Then you can track sediment transport. This in the water industry, when you know what where there's so much sediment, you can create a sediment trap such that these sediments are dropped before they get into the dam, so you don't have too much issues with dredging. And then you can also identify the seasonal patterns. When it rains, you expect there is much more turbidity. When there's no much rain, you don't expect so much turbidity, or vice versa, depending on the region you are at. And then the next one that is used so much in agriculture is checking for erosion events. and algae blooms. Like this is what you see, like there's so much algae in the water, and then that translates to issues with oxygen and carbon sequestration. So there's some of the things that you apply the result from whatever you have done into. So and so at that point, we have a question. Yes, Evans.
So,
Yep.
how to learn to include in data to this kind.
You
Oh, my concern was,
yep.
suppose you wanted to, and my concern was, suppose you wanted to include maybe population data for this, and you get to you want to understand at
Yep.
this portion of the river, at this section,
Yep.
perhaps the population there is so high, that's why
Yep.
the water is
Turbid.
highly turbid. So
So
how could you include such?
that one you just add another function. So what you do is like let's see if we have something in Google Earth Engine. See
Yes.
Earth Engine. I usually, whenever I want to do anything, I always look whether Google Earth Engine has anything like that I need, because Google Earth Engine has a way of. So what you do, Google Earth Engine has so much data.
Yes.
Sometimes you actually don't know what exists and what doesn't exist. So, like right
Yeah.
now, this is all the data we can find that has population. I can see most of it is is tagged in the US. Okay. So it's about census. I'm just looking through the catalog. But what you would do, you would. I was trying to look for a very specific image. There's an image that calculates population densities across the area. So let's go back to our code example. Now this is outside our code. First of all, this is domain knowledge. You can see here, before we get here, where our area is, we have a bigger area, which is the catchment, isn't it?
Yes.
So what you would do is you would get all the you get your catchment and get all your rivers. The problem is some of the rivers are covered by trees, so you don't see them through the satellite. So you need to be able to remove the trees. So that's another step. But assuming that all the rivers are open, yeah,
Yes.
you would get all the population in your catchment, and you get the population density. And then you compare your population density with the section, whichever section you are at, you compare population density at a given section with the turbidity at that place. So it's doable. You just add it as another function in our code. The same code we are writing, you can add so much until you have no space left here for the things you have calculated. And then, or another way is there's something we call in Strimlit, there's something we call moat app. You can create another app within here that you open. This one is for NDWI, this is for NDTI, this for population distribution, this is for how they have interacted together and what has come out of it. So that's how you whichever data you are thinking about right now, you can actually add it to this analysis. In fact, even the data that doesn't exist on Google Earth Engine, as of now, if you're using Google Earth Engine for a while, you can just come in here and add your own assets, isn't it? Like if I look here, if I look at assets, you see I have so many assets somewhere. For now, I have not logged in well, so it's I need to restart that. But what you do is any image or shape file that you think you want to use, you can just add it as an asset here, and then you can use it for you can add it to your asset folder here, and then you can use that to whatever analysis. You can just call it this normal, call it from the cloud, what we call cloud optimized GeoTIFF. Okay, guys, any other question? I don't know, Christopher, how many have how?
So I think let me check. So anyone with a question, feel free to ask either in the chat or you raise a hand. So maybe a question. I think it's a very simple one.
Yep.
So is it possible? So let's say you have a shapefile.
Yeah.
Now, in this case, now instead of using the coordinates, you get the coordinates. You have that shapefile with different, let's say, categories. So let's say is a country and county.
For me, is the coordinates. It was take this faster as a code. In reality, I can just add here another the code,
Yes.
the coordinates.
Yes.
Just upload a shapefile.
Ah, nice.
Yes, and then that shapefile will be used to as the for your river or whatever area you want to do. Just add it up. If I remove this constraint for having to use the 2-kilometer buffer area as the only area we calculate our NDTI, it could potentially calculate for the entire planet.
Yeah. So thank you. Yeah, thank you. And then maybe another question. I've not interacted with the now in production.
Yep.
Can you deploy this now the streaming app, and where can you now deploy it?
Let me. I hope to navigate. Let me first of all take this out so that I don't share secrets with the. I might have some secrets that it might open in the cloud.
Sure.
Okay. This is where you deploy it. First of all, this is the easiest way to deploy it. Okay?
Community cloud. Yeah.
Yes, nice. For the community cloud, Streamlit community cloud. This is the easiest way to deploy a Streamlit app. But if you are adventurous, you can deploy this in any other way. You can deploy it in Cloud Functions. You can deploy it in Cloud Run, and any other host where you host your application. Because basically, isn't this the same way you call UVCon LAN Fast API?
Yeah, sure.
In a Fast API. So the same way, it's just now you are replacing something like UVCon with. Let me find an app that I have already hosted. I don't know whether I have one. Let me see. I usually host them and then drop them out. So yeah, it's hostable, and then you can use it. You can now share this with multiple people, and it doesn't really. It doesn't. Yes, like Muigai has said, you can also do it on Heroku. And Muiga has a question, so I don't know.
Hello.
Yes.
Well, I wanted to. I was inquiring whether we can whether your code is on GitHub.
No, I have not shared it. It needs something. I needed to use. I need to add something to do with it being able to import a shapefile, or just use the either to use the coordinate you give it or use a shapefile. But I can even share it as it is now. But I haven't put it on GitHub. But when the video is ready, when Wanjohi is sharing it, it will have it.
Okay. Then maybe you could give us your GitHub link.
Okay, that one is easy. I can get it.
Thank you so much, John.
You're welcome. Okay. I've shared my GitHub link on the okay. There you go. So yeah, use Streamlit Cloud. I don't know whether I should share that with the. And you can do many other ways. You know, like this time I have used Streamlit. You can do this in Flask, in Fast API, in Django. You just need to, if you do develop these things, it's just the same thing. And you can also use this. All this code can also be a Jupyter notebook. So you really, there's so many ways of doing this once you have the code right.
So thank you. Yes. So thank you.
Yeah, I'm trying to get one application that I had shared. I don't know. So yeah, like you can see, this one is a hosted application. I haven't used it for a while, so like now it's doing what we call baking. Can you see? Let it run. So like this application is just, yeah, it's there on the web, but I had used it to calculate to figure out how far you can go given a few from a single point. Say you have entered this is the point that you the longitude, and then from there, using the railway, how far can you go in 10 kilometers? So that's what I was doing. Like if we increase this to 20, should recalculate and tell you this is how far you would have reached, and the point where you should write your railway. This is using free data that's available. It's called from, what do we call it? This OpenStreet. OpenStreet has a nice route network data, so you use that to calculate also things. So right now it's centering somewhere in London, but you can do the same for Nairobi. But Nairobi you don't have railways, so probably you need to use roads. Okay.
Yes.
Yes.
Yep. So something like that.
So anyone else with a question? I think today we have learned a lot. Some assumptions we had made on setting up the cloud project. I think today, John, you have helped us and our members understand how to set up, and then import it on the Python project, Python now API. So I think that's something that we had not thought as important, but I found it now very important because most people don't know how now they can access that API now locally or now using the Python API.
Yeah.
Yeah. So thank you so much for that. The other thing was on we had not done specifically an app from using our GE. So I think this is another thing that is very good, using Streamlit, visualizing. Yeah, so this was a very good presentation. So I think anyone with a question, a concern.
I can see one from Evans.
Okay.
Evans is asking why we are not using the GE console, and the answer is GE console uses JavaScript. While our code we were using Python. That's the difference. And also, maybe you guys have figured it out. I find it very hard to get to work on GE or using on the console and create the app the way I want it to work. You see, you can't, unless you know this is actually GE, you find this app, you won't know it's GE. Am I right?
Sure. Yes.
Yeah, so that's why I don't use the GE console much, because most of the people you work with, most of the analysis you want to do, people don't really care where you are doing it. They just need the answer. And so this one, that means, you see, I've created for you this application for NDWI. Now, if somebody wants an answer for somewhere tomorrow and they are willing to pay me, I actually don't have to redo the code. I just ask where it is and just run it and just give me my money. So that's why I kind of always move away from Earth engine, so that I can learn this. I can actually even tell you, oh, I have a link somewhere. Give me your credentials, and you go. Yes, Francis. Yes, you can add. You can add all these charts and graphs. You can add a time series on this. You just calculate all these values on a time series. You can even add what we call a time slice, or a slice of this, and then you can slide and see like how the stability is changing. There's so much more you can do. Like once you have this setup, like it's just more code. It's just not yes. So you can do all those things.
And now, Mr. John,
Yep.
suppose now you are mapping a stream of river whereby it has some mangrove crossing and catching each other. So how would you be able to assess the stability when the mangrove is crouching and maybe limiting the satellite images to
So that one, now you use different methods. The whole idea is for satellite image, if you can see it on satellite, means it's open. If it's crossed, there's no way. It's like the same way I was telling you, like you see a month with clouds,
yes,
and you can't really do much. You can try to get out the cloud, but then you'll be left with an empty image. Yes, so that's the thing. Like now for mangrove, what you would check is the exit of the mangrove, where the mangrove ends and the water streams now enters into the ocean. How is the stability to that section? And then you can use other ways now from this. Also, so now you can start using other methods of analysis to identify whether there has been an issue on the mangrove itself. Now, at that point, your analysis will not be turbidity. Turbidity at the end is what you have. And then now the mangrove itself, what has been happening to it? Because if it's pollution, it's probably fading.
Yes.
Yeah, so you have, that's the balance. Like it all depends on what's the answer you are looking for. If this satellite way of looking at stability doesn't exist here, there's no way you can do it other trees. You can do a lot of other analysis. You can actually use You see, we are using, let me see, we are using this image called the Copernicus satellite image. There's also so many other images there, like you can use. You can also use this some that actually measure pollution. Like it will measure CO2 and then it will measure ozone. And then if you using domain knowledge, you can actually identify an issue happening by just looking at all those results.
Yes, yes.
Francis, not quite. I haven't used it. Maybe it's possible, but that's only possible the way it calculates depth. These images called radar. Radar images. And these images, if you have a radar image, sometimes they penetrate to the ground for 50 meters, and you can do pretty much a lot with it. You can actually even identify aquifers using these images, not just the surface. And this is the one you would want to use when you are, like Nicholas had said, when you want to look underneath the trees. This is probably the imagery you'll be looking up. But then these radar images are quite expensive. They are never readily available. So yeah, but it's possible.
I think this is really, really encouraging and also exciting for us to learn by it. Because since we started our GE sessions, we didn't try to make any application anyhow, which is nice to have learned today. And as Christopher had mentioned, we didn't start from the basics. Our assumptions was that most of us are developers and have interacted with the virtual environment.
Yeah.
So that was an assumption. We're going to look into this in the subsequent sessions. And thank you so much, John, for helping us recognize this.
Okay.
So, for the community, today we have learned so much and so good information regarding uh, Google Earth Engine and its capabilities. And you remember that we had last session, now that was on a Saturday, that our speaker introduced to us a challenge whereby she wanted us to try a challenge, to try to do a project which was related to whatever now our today's speaker John has taught us today. I think this was a really nice coincidence because we were given a challenge which was exactly related to whatever our next session was going to cover. Because even for you, John, your session was planned way back, so many months ahead.
Yep.
And we didn't expect that we'll be given such a kind of a challenge. And then this is something which is coming at a very nice time, whereby you come to teach us when we have already the previous Saturday we had been given a challenge to try. I think that was really nice. And at this time we have a starting point. At least every one of us know where to get started from. And since we won't want to try most of the complicated things, this is a challenge. It's just a practice project which we would love to make it grow. Our first, we can say, we won't say it an hackathon, but it's just a community project. So we thought that if with your generosity,
Yep.
with your if you would we already have a structure of our project of how we wanted, of how we had thought prior to your coming, how
Yeah.
the project would look like. But
Sure.
now here with your expertise, we
Yep.
thought we could engage you so that you can help us refine our process flow, our project flow for water quality mapping. How the project was intended to be is that we were trying to map the pollution for Nairobi River. So we tried to assess the pollution,
Yep.
all the all the causes of pollution, and also the turbidity of that river, how it has changed over time, and what are the causes, the major causes of pollution for that river. Now that was our challenge which we were given to try
Okay.
with all our knowledge.
Yep. So
So
that can be doable in this, but for urban areas, I would recommend looking for a better image analysis, satellite imagery, and then if it's something that you can get funding from somewhere or through the community, this imagery this guys called Planet Labs. They have a satellite image for the every part of the earth every day, and it's at 3 meters. And they have all their images hosted in Google Cloud. So yes.
okay, so what you did the project is just for free trying for community. So we won't say that we have money to, to pay for this. So we were preferably going to use the Google Earth Engine catalog dataset.
Okay.
Yeah.
So if you need some help, you can always give me a call.
Yes.
Yep.
All right.
Okay.
So thank you for that, John. And also for the community, for this project, what we would request from you is that you should express interest. We were to give you to share a form
Yep.
in which all of you, all those participants who are willing to participate in the project can express interest with their areas of expertise. Like now, if it's for web, you can be able to make for us a very nice dashboard like the one as light. Then another person who is good in the image processing, we can also participate in that. Also, all the processes, the steps we have undergone in this project, that could be really nice because it's a collaborative project. All of you could share their skills and their expertise in this and make sure that it works best for all of us. It is going to be an open source, so we are going to create an GitHub repository for that so that anyone you can push all the changes that we have worked on. Every part that you have played, you put it in that. So we are going to share with you so that you can share, you can a form which also has area to select your area of expertise, whereby you can in that, if you are expert in that section, you will be able to take charge of that section. Then I'm good in another part.